Thierry Damiba, and I'm a data scientist and developer advocate at Qdrant. Today we're going to be talking about how to build GraphRAG using Neo4j and Qdrant. Large language models, or LLMs, have incredible reasoning capabilities, but they often struggle to connect information as intuitively as humans do. Traditional RAG methods, which enhance LLMs with retrieval-based information from a vector database, frequently miss crucial connections when dealing with complex holistic data. GraphRAG is an approach that overcomes some of the limitations of traditional RAG by combining vector databases with graph databases. Let's take a look at a GraphRAG demo so we can understand how it differs from traditional RAG. We have here a simple data set of 25 sentences that all relate to people, places, or things. So for example, we might say Alice is a data scientist somewhere, or Frank reports to the New York office. So we've got all these sentences, and we want to query these sentences to ask, what is Bob's connection to New York? And on the left here, we're going to start with a traditional RAG to start. You can see that when we ask, how is Bob connected to New York? The context does not provide information on Bob's connection to New York. We can see here the documents that were retrieved when we queried how is Bob connected to New York, and none of them mention why Bob might be connected to New York directly. Now, let's take a look at the output from the GraphRAG. Here, when we ask, how is Bob connected to New York, we get this answer, which is Bob is connected to New York through various ways according to the graph. He collaborates with Carol on the Alpha project. Carol collaborates with Bob. There's also Dave involved. So the GraphRAG was able to give us a complete answer because it understands the relationships and the entities inside of our data. Let's take a look at the architecture of GraphRAG. We'll start with ingestion, and then we'll talk about retrieval and generation. In the ingestion phase, raw data is processed into both an ontology and vector representation. The ontology is stored in a graph database like Neo4j, while the vector embeddings are stored in a vector database like Qdrant. Unique IDs link the two databases to enable cross-referencing. In the retrieval and generation phase, a user's query is first converted into a vector, and then a semantic search is performed in Qdrant to fetch to relevant documents. In a traditional RAG system, we would go straight to the generation, but since we're in a GraphRAG system, we're actually going to have the IDs be passed to query Neo4j for contextual relationships, and finally, the combined context is passed to an LLM to generate a refined answer. GraphRAG works great for certain use cases, but it's not a silver bullet. Here's a few things to keep in mind. First, the LLM is responsible for constructing the knowledge graph. In our implementation, we use the LLM to extract the ontology, which is going to give you better results. But you have to keep in mind that once the graph is constructed, the LLM is going to translate human queries into Cypher, which is Neo4j's language, and you might have issues with translation there. And finally, you have to keep in mind scalability and cost because, of course, every time that you hit the LLM, that's going to increase your runtime and it's also going to increase your costs. So these are some of the things that you should keep in mind when you are running a GraphRAG. To run this app, you're going to need a Qdrant key and a Qdrant URL. You can get both of those from the Qdrant website. You're also going to need a URI, a password, and a username for Neo4j. You can also get those on the Neo4j website. Finally, you're going to need an OpenAI API key. You can get that from the OpenAI website. Now that we've got all our imports set up, let's dive into the code. First, we're going to import all the libraries that we need to run this application. The important ones, of course, are Neo4j and Qdrant, but we're also going to be importing some helper libraries to help us run this application. Then we're going to load up our env.local, and we're going to load all the environment variables. We're also going to print some debugging information so that if we have an issue with an environment variables, we know which one it is. The next step is to initialize the OpenAI, Qdrant, and Neo4j clients, which we are doing here, and those are the three clients that we're going to be using in this application. Here we have the first code that's going to relate to Neo4j, which is us defining an output parser. So you can imagine we need to tell Neo4j, hey, how we want to output the parsing of the data, because by default, if we don't tell it exactly how to do it, it might come out with something wonky. So we're in here actually defining a class that's going to be our base model for the graph components as well as the entities inside of the graph. Then we've got our OpenAI LLM parser, which is going to be a graph relationship extractor. So we're going to give it text, and then it's going to format that text as JSON objects with the exact structure that we have provided here. So that's going to help us take that data that we input and actually turn it into something that the graph can use. So then we have our next function where we're actually going to extract the graph components. So we have our prompt here where we extract nodes and relationships from the following text, which is the raw data that we saw earlier. And in here, we're going to find the relationships as well as the nodes. And basically, we're going to add the nodes to the dictionary with a unique ID. And we're also going to add relationships to the relationship list with node IDs. And the idea here is that the IDs will carry over from Qdrant to Neo4j so that the search knows how to talk to itself. And then we're going to ingest the data with Neo4j. So you can see here we have a SQL query where we're creating the table and then we're matching as well as creating, and we've got our relationships inside of there. Next step is we're going to create a Qdrant collection, and we've got some code in here to check if the collection is already created. If it is, then we're going to overwrite that collection. If it's not, then we're going to create it and write our information. Then we're going to generate our embeddings. Next, we're actually going to ingest that data into Qdrant. So you can see here, we're taking our embeddings and we're actually getting that ID, so we'll be able to match it back up with Neo4j and putting it into Qdrant, and then we're printing out the ingest and complete when it's all complete. And then we're building our retriever. So here is the initial vector search with a top K of 5. That's the same K that we used with the traditional RAG. So it's going to retrieve those top 5 IDs for the nodes. And then here we actually have the logic that we're using to query Neo4j. So you can see this looks like a SQL query because the data that we have is more or less going to be put into Neo4j as a SQL query. So the next step is actually setting up the graph context. So we're going to take our entities, the related node, the relationships, and actually create that graph where we have the nodes and the edges, where the nodes are the people and the edges are how they're connected. And then we're actually going to run the graph where we tell the LLM, you're an intelligent assistant. Here are the things that you have access to, which are nodes and edges. And using that, please answer whatever the user query is. And then we actually have the end-to-end pipeline here that is going to allow us to run the script. You can see the raw data that I showed you earlier, and you can also see that same query. So now that we've walked through how the app works, let's actually run it again and take a closer look at the output. And you'll see here we have our environment variables, which of course we're not actually going to print. And we see that the script started, we loaded the variables, we initialized the clients, we created the collection. The collection already existed, so we skipped creating it. We're now extracting the graph components, and it's going to take a second. Once again, one of the challenges that you have with GraphRAG is it's going to take more time than running the traditional RAG, right? You can run the traditional RAG after this and you'll see how much faster it is, but that is the trade-off that you're making for richer answers to your query. So here we can see that we've extracted these graph components, and you can see that they have these unique IDs. So we have different types where it's works at, previously worked at DataCo, works on with clients on relations, collaborated on previous projects. So Neo4j has been able to come in here and pick up pretty accurately some of the relationships that we have inside of our data. So now that we've actually picked up these relationships, what we want to do is go into Qdrant, and we're going to put this data into Qdrant along with the IDs so that when we run our search, not only will we get the data that we have inside of the vector store, we will also have access to the data inside of the GraphRAG. So here we see, okay, here is the vector search. Here are the things that were pulled back: the Seattle office, the Alpha project, the team, both offices, and Frank. And then we can actually see the particular retriever results, which are Alpha project. We see the ID. We actually see the score of the search as well. So these are going to be all the different entities, and you can see that there's quite a bit. Now at the bottom here, what you can see is we actually have the nodes and the edges. So here we have nodes of multiple location, team, etc. And then we have these edges, which are going to be kind of the facts, right? And they don't all make sense in terms of English, right? Seattle office works at Alice. Well, no, Alice works at Seattle office, but by putting in the data this way, we have this representation where the LLM is able to understand the relationship between Seattle, Alice, and the office. So now when we ask how is Bob connected to New York, we get that full vibrant answer where he's connected through numerous paths actually, and here are all the paths. And once again, I'm going to run the traditional RAG one final time so you'll see, first of all, there is that huge speed difference, right, where it's going through everything much faster because it doesn't have to pull out the entities and the relationship. And second of all, it is not going to be able to actually successfully answer the question because the context that it pulls out does not provide information on Bob's connection to New York. So that's GraphRAG with Neo4j and Qdrant. I hope you enjoyed this video. If you have any questions, please feel free to reach out to us on Discord. We'd love to hear how you're using GraphRAG. Thank you.